Now let's go over the answers to the student practice. The first one has factors in front of the log, so we're going to rewrite those as exponents. So we'll have the natural log of x squared plus the natural log of x plus 5 to the 1/3. We have the sum of two logs, which is the log of a product, so that would be x squared times x plus 5 raised to the 1/3, and then close the parentheses. Again, depending on how you're asked to leave your answer, if you're asked to leave it in radical form, then what would also be acceptable is x squared times the cube root of x plus 5. All right, this next one, this is one of the ones that you really can take a pretty big shortcut. There are no factors in front of the logs. We just need to decide which factors will be in the numerator and which will be in the denominator in the argument. So the w and the y both come from positive logs, so my numerator will have wy. The x and the z, those are with negative logs, so those will be in the denominator. Last one. I first want to distribute the 2, so I'll have 1/4 log base b of 5 minus 2 log base b of 7. Don't forget to distribute that negative, so it's going to be minus 20 log base b of y. Now the next move would be to rewrite those factors in front of the logs as exponents. So I'm going to have the log base b of 5 to the 1/4 minus the log base b of 7 squared minus the log base b of y to the 20th. We'll come up here and rewrite this as one log. Again, we've got the 5 to the 1/4 is with a positive log, the other two are negative logs, so the 7 squared, which would be 49, so we get 49 y to the 20th. Alright, the last property that we want to look at in this case is a formula. It's called the change of base formula. And you'll notice that when you, let's open the calculator. If you open your calculator, you'll notice that there's an LOG button, which is right here, LOG, and then there's an LN button. So your calculator has a button for common logs and it has a button for natural logs, but it doesn't have a button for logs with other bases. And so we have what's called the change of base formula. There is a proof for this in another video. Again, I ask you to be curious and kind of check out the proof so you can see where this came from, although you won't be required to prove anything on an exam in this class. Alright, so let's take a look at this. The log base b of m, the change of base formula basically says that's going to be the same as the log of the argument divided by the log of the base using any base that you want. Since we can use any base that we want, and if we want to evaluate using our calculator, we would choose to use a base of 10 or a base of e. And so you'll get the same answer for either one. So let's look at the first one. It says use the change of base formula to evaluate the following logarithmic expressions. Round your answer to the nearest hundredth. So using common logs, we would write this as the log of 7 base 4 would be the log of 7. It's the log of the argument over the log of the base. And we'll approximate our answer. Let's pull up our calculator. So we'll have LOG 7 divided by LOG 4. Hit enter. Let's keep about 4 decimal places just so we can compare it. Be 1.4037. And now we'll do the same thing using natural logs. So it would be the natural log of 7 over the natural log of 4. We'll type this in our calculator. Natural log of 7 divided by the natural log of 4. All right. And so you get the same exact answer for each one. So what I'd like you to do now is just pause the video And just try student practice number 7, the log base 5 of 13. Evaluate that. In this case, you can round it to the nearest hundredth. All right, let's evaluate these. Clear out the other two. So if I have the log of 13 base 5, I'm going to, using common logs, that will equal the log of 13 divided by the log of 5. And using natural logs, that would be the natural log of 13 divided by the natural log of 5. So let's do both of these on our calculator at the same time. We've got log 13. Close those parentheses, divided by the log of 5. And then we'll take the log, the natural log, ln, of 13, and divide it by the natural log of 5. And you see we get the same exact answer. And so to round this to the nearest hundredth, it would be 1.59 for both of these. And of course, if we rounded both of these to the nearest hundredth, we get 1.40.